everyone. Here to talk to you today a little bit about generating highly reliable FTIR data in the field and doing that with validations to assure quality assurance, accuracy, and just making sure that your test teams, whoever you may have on site, whether it's us or not, are doing the job correctly. My name is Blake Erickson. I'm with Montrose Environmental, and I am doing this with Phil Copy, who could not be on today, but he did help generate some of the validation slides. So I thank him in advance because without him, I could not have gotten this presentation done. So jumping into it, we want to talk about some of the basic, what we've seen out in the field in terms of FTIR testing. The FTIR notoriously is a really powerful instrument, but it's really easy to collect poor data. So we'll talk about how challenging field testing is, typical equipment mistakes that we see, and really how these small errors over time really compound and make your problems massive. And before you know it, you might be screaming for help. We want to talk about QA/QC, what the methods are requiring, what states are asking for, what the EPA is thinking, and why this is so important. And then we're just going to wrap it up with the end goal. Where do we want to see the FTIR? Where do we want to see other test firms be with this instrument? It has a ways to go, but we're on the right path. So field testing is tough. We all kind of understand a little bit of the dynamics of stack testing, and we do know that it is notoriously very hard to do. When it comes to FTIR testing, I can't stress this enough, cleanliness is everything. A lot of test firms will go from site to site, location to location, industry to industry. They'll go from a cement plant to a power plant to a chemical plant. They're constantly mobilizing, they're constantly traveling. Once again, I don't fault any of the test teams that do this line of work. It's notoriously difficult. But when you're going to be running an advanced instrument like the FTIR or the upgraded FTIRs, you need to make sure that your sampling systems are in really good working order. We tend to recommend dedicated sampling systems for each instrument. I know that's not always ideal, but if I was the customer, I would be making really sure that the equipment was clean and in good working order, because no matter how good of a spectroscopist, FTIR operator, whatever you want to call the person running the FTIR is, you're only as good as your equipment. You're never going to pass a spike when you have faulty equipment. This is largely based around temperature swings. If your heated lines fail or if they can't get up to calibration temperatures, the FTIR samples hot and fast. That's what we always like to see. There shouldn't be cold spots. The temperatures that you're sampling at should be matching your instrument and the references that you're using. That's one of the big things that we see with other firms out there. We'll get to that in a little bit. And like anything else, to direct your attention to the bottom right picture, we do a lot of servicing of instruments where customers or other firms will send us their FTIRs for maintenance, generally the 2030 MKS model. And things happen over time. You can see in this picture, over probably many years, this FTIR, knock on wood, probably was performing okay, but they noticed that over time, their signal strength would slowly decrease as the ambient temperature increased throughout the day. And they noticed that the fan was dying. Now, this is a really odd and rare problem because those fans should just be cooking all day, every day. And it turns out the fan was fine. It was just being blocked by a tremendous amount of dust and just dirtiness. So keep your stuff clean. Make sure the instrument is in good, healthy order. We'll get to that in a little bit. But understand that, once again, things happen. Start your way from the top down. Start with your probe, make sure everything's hot, start with the heated line, make sure things are filtered. There is a little bit of argument, but I'll get into that into the following slides as to where the filtration should be. And just make sure you have a really good maintenance program with your FTIRs, or that you require your stack testing teams to have a good maintenance and tagging program. So aside from equipment, a healthy instrument is also critical. Especially with the amount of travel that these instruments go through, things happen. We derive our absorbance data basically from our single beam, which is derived from the interferogram. If there's any step along the way, we won't go in too much of a detail here. This is more of a high level approach. If you have impacts to your single beam, and in this case with this instrument, the single beam is actually not all that strong. We like to see, out of the box, that signal beam strength, we measure right around 2,500 Wade number, should be more or less around 1 or a little greater than 1, hopefully. The better the signal, the better your signal to noise, the lower your detection, and the better your resolution. So on the screen to the right, where you can see, most of the analytes of interest, like formaldehyde, methane, certain gases aren't going to be as affected by an unhealthy instrument. You'll still be able to collect good data for the most part. But if you're looking at really low level detections, parts per billion detections, or things that are, what we call sticky, or they're going to react to temperatures much more readily, your formaldehyde, ammonia, SO2, acid gases, things along those lines, your instrument needs to be in really good shape, because you can't claim ultra low detection and have a poor instrument. It doesn't work. Taking these two thoughts into consideration, once again, cleanliness is everything here. Typical field mistakes that we've seen. I will say we have worked with a lot of testing firms. Generally, we are subcontracted quite a bit by lots of stack testing companies out in the country. We have hundreds and hundreds of tests under our belt, and we've seen pretty much anything that you can't expect to see out in the field. So these are our typical, they're far too common in our industry. We hope that we can eventually kind of sweep these out and get rid of them one day, but one step at a time, just being aware of what the problems are. A lot of firms treat the FTIR like other analyzers. This is a laboratory grade instrument that has been essentially retrofitted for stack testing. Stack testing is difficult, and this poor care of these instruments over time really impact data quality. One of the big things that we're seeing, and this is something that's very important for states and regulatory agencies to understand, is the improper use of span factors with an FTIR. Unlike other methods, we're really just verifying that calibration, whether it's a linear, quartic, whatever it may be, line is correct. We're not doing a high, mid, and low. And so the calibration gases are so critical. Direct values should be really close to the certs. If there's anything that is majorly off, there's likely something else going on with the instrument. Spanning the instrument to say that the gas is actually this is not always the best method. You especially should never do this to your CTS, your analytes of interest. There are times where it's okay, but your span factors, as soon as they get a little higher than 5%, you want to look at your instrument, you want to look at your calibrations. There's something else going on behind the scenes. Just spanning it to tell it what it should be is not the correct way to collect good FTIR data. And one thing to note with that, the beauty of the FTIR, we can always go back and manually check the data. We'll get to that in the validation step. But just because the FTIR is saying it's this number does not mean that it's always correct. So you really need to make sure that your calibrations, your recipes, all that is up to date and in really good working order. Rushing to get the job done. I won't spend too much time on this, but stack testing, notoriously for wanting to get back home, back on the road. The pre-test and post-test checks for this analyzer, we want to challenge the instrument for every single project that we're doing. It's so important. Skipping these processes, there's a list of certain things we'll get into a little bit later that if you do these, you can essentially ensure a good quality stack test with your FTIR. But if you skip these and just go right into testing, you're flying blind. You're not exactly sure. And this leads into not monitoring your temperatures, your pressures. These, the concentrations are derived from temperatures, pressures, and a handful of other things. These are very, very critical steps. If that heated line goes down, you're going to start to scrub. You might get, off gassing. There's a whole slew of things that can happen just based around temperature. So make sure that your sampling systems are in good working order. Lack of training is probably the number one killer when it comes to our industry and those who are running the FTIR. One of the things that scares us tremendously is when someone says, yeah, I'm dangerous with the FTIR. And I sometimes ask, well, are you endangering yourself? Or, I don't like that. You should be really good and you should have a lot of confidence in whoever is doing your FTIR testing. So be wary of when someone says they're dangerous with an FTIR. Stack testing is notorious for really, there's no true barriers of entry. Anyone can really buy an FTIR, go out there and start running the test. To me, I don't like that, but there's a reason that larger firms have the reputations that they do. They spend a lot of money on the accreditations, and there's a reason for that. Just because going for the bottom dollar is not always the best choice. You don't know what you're always going to get with that. And sometimes those accreditations pay for themselves. So with that, we tend to see all around the country a lot of learning on the fly. A lot of, I've read the manual 20 years ago. I'm going to pass it down. It's like the game of telephone. Once it gets to the last guy, he can probably turn the analyzer on and might be able to run it, but that doesn't mean he's going to collect good data. The hand-me-down training programs goes into play with that. And with that, kind of goes back to my first point of things become outdated. A lot of calibrations have come a long way. The calibrations that you may have been sent with several years ago probably need to be looked at and improved upon. And there's just better recipes that have been developed over time for certain and specific sources. So make sure you reach out. We always say, the last point here, not asking for help. There's really good firms out there that really know their stuff with FTIRs. Ask for help. There's lots of experts out there. Any one of these firms would be happy to assist, whether you're the customer or a fellow tester. Let us know. Going back to the last slide, improper use of filtration. We believe in filtering right at the top, right behind the probe, so your heated line is nice and filtered. There is an argument here as to whether that's needed or not, but to me, good scientific process, you're keeping your line clean. If you have filtration after the heated line, you're potentially building up a bunch of gunk in there, which could lead to off-gassing, could be impacting the sample. Once again, lots of arguments back and forth, but we find best practice, filter at the top of the system. From there, misunderstanding method, 320 or ASTM 6348. These are complex methods. They've been around for a while, and some firms have been flying a little looser than others because some state regulatory agencies just don't have the bandwidth to fully understand this instrumentation. I once again, let us know. If you have any questions, let us know. We're happy to help. And one of the last ones is in terms of storing data, back up your data. I can't tell you how many times I've heard of, the laptop got rained on, or even sometimes trucks have been broken into and they've lost, several thousands of dollars, if not hundreds of thousands of dollars of data. It's just gone. So back it up, put it on a secure server for not only your sake, but for the customer's sake. This is very confidential data. That step is extremely critical. Protect your customers. And with that too, store your data in single beams or igrams. That way the data can be looked at a later time, possibly reprocessed if we were missing a gas in the recipe or a matrix. We'll get into that a little bit more. So We have the test data. We kind of understand what to look for on the sampling side, but how does this impact your data? Once more, it's not the loss of temperatures and, a little bit dirty of an instrument is not going to really impact your NOx, your CO too much. It will at a certain point, but for the most part, you'll be okay. But this is going to greatly impact your low-level detection analytes, especially if you're using a star boost or a new upgraded FTIR with different path lengths. These advanced instrumentation pieces will take the greatest hit. It compounds much more. You're looking at parts per billion. So if you lose half your signal, you can't really claim that you have 10 parts per billion detection. It's not good science, and the math doesn't make any sense. You're going to likely bias your numbers. Once more, the FTIR will spit out a number. That doesn't mean that the number is correct. There is one critical step that you need to do in order to make sure that you are collecting really high quality data, and far too many firms skip that step. This leads to inaccurate analysis, and the QA/QC can be shaky at best. So make sure you understand the methodology and make sure you're following it very closely. They were written for a reason. This is a screenshot of the Star Boost FTIR, and what the Star Boost is an optically enhanced FTIR, so we can get really, really low detection limits on certain compounds like formaldehyde, ethylene oxide, CO, a handful of others. So you can see the window of analysis here is really tight. We're looking at a very fine band for where formaldehyde absorbs. Formaldehyde absorbs really well around that 2800 wave number, but you can see your single beam on your y-axis there. Now, if that single beam drops during testing, whether it's from particulate, from temperature swings, whatever it may be, it's going to impact your data. You might be thinking that you're seeing 10 ppb formaldehyde, but in all reality, it might be higher, it might be lower. In order to know, you need to validate the data. It all goes back to understanding the methodology, using the correct calibration gases, avoiding span factors. You do not span your CTS. That's a big no-no that we have seen. And understand how sensitive these instruments are. Ambient temperatures really dictate the health of the instrument in the field. In a perfect world, you'd be in a 75-degree Fahrenheit room with no wind, nothing, but we do stack testing. So you're going to be in a trailer, potentially 100-degree day with AC units struggling to get cool. So you're going to see some swings. Once you have the data and you bring it back to the office, you might be just an FTIR operator and you don't do the data handling, you hand it off to someone else. That's fine, but you should really understand how the data is handled from start to finish, from equipment to the reporting. They're all critical steps. So how do we know we did a good job? You might be finding yourself asking, you're looking at the data set as a data manager and you're like, there's no way this number is real. The QA/QC doesn't make sense. Unfortunately, one of the things that we see, go into Excel, you can change the number. That's a poor way of handling the data. Once again, if you're collecting the single beams and the interferograms, a firm that is very reputable can go back. The FTIR, I always say, takes pictures of the spectra. We can take the data and we can look at it from the spectra point. We can do a manual validation. And that step is single-handedly one of the most important steps that all firms should be doing. In state regulatory agencies, the EPA should know that. If you're a customer, you should know that. Ask your testing firms, are they validating their data? Because if they're unsure, you might want to contact someone else just to make sure that that step is being done. When the data is being collected correctly, we can modify recipes, we can reprocess, and there's nothing wrong with reprocessing. It's just ensuring that the data we are collecting is accurate and precise. We can add gases into the mix to clean up our analysis, or if there's another large interferent, we want to incorporate that into the spectra. The idea with the FTIR is we're looking at a wide range. And we want to include the entire gas matrix to make sure we're collecting good data. So what is FTIR validation? FTIR validation is a critical step, as I previously mentioned, that needs to be done. It needs to be involved in your testing program. If you're using an FTIR, it needs to happen. We space it out here in basically to 3 verticals. So you have your diagnostics, your data analysis, and your QA/QC. In terms of your diagnostics, it's going to confirm that your instrument is in good shape. You're going to be looking at the line shape, signal intensity, signal to noise ratio, and a slew of other things. Your validations are going to make sure that the instrument is healthy and it's doing its job. It's also going to confirm whether the FTIR is the best fit for the job. And the FTIR is very powerful, but there are other methods and alternatives that might be the best method, better method to use. In terms of data analysis, this is after we've collected, sampled. We want to manually check with a reference spectra to make sure that the data we're collecting on site is accurate. So for a quick example, if we think the moisture is 10%, we want to make sure. So we take a 10% reference of moisture and we will overlay it, and we do what's called a subtraction. If that subtracts out nicely, we have a good data collection. If the water that the FTIR is saying is, say, 50%, then we have a problem. We need to change our calibrations, we need to modify, we need to reprocess. And that's why validation is so important. We're taking the reference and we're checking the sample. This goes into the back to the reprocessing. We can optimize the method. We can add gases into the matrix. We can take something that might not be needed out to help with validation. Basically, it's going to enhance your data set. In terms of QA/QC, analyte spiking is arguably one of the most important piece of criteria that we do in the FTIR world. We're taking a very small slipstream of calibration gas, introducing it into the sample, and we're hopefully getting a good recovery down. So usually we're looking at about a dilution factor of 10% or less. And, we're spiking ppm, sometimes ppb into a stack, and we're hopefully getting a good recovery. It's a really, really good, powerful piece of QA/QC to not only ensure that your sampling systems are working correctly, but that your methods and recipes are good. Of course, the CTS, the calibration transfer standard, ethylene is a common one for us in the FTIR world. Ethylene is extremely stable, and basically we'll use that to ensure we're getting a good sample recovery from top down too. So we'll send the calibration up from the ground to the probe tip, back down, 100% recovery, you're good to test. This is a little example in terms of why this is important. And this is the actual method analyzer for subtracting specific compounds. So this can be found in your multi-gas software set. This comes with it. And so there's really no excuse to say that you don't have the software to do it. It's there. And this is why this is so critical and important. And what this is essentially you're confirming that the concentration data is accurate. So in this case, we are looking particularly at methanol. And long story short, the FTIR was saying that the methanol was non-detect. It believed it was below 0.5 ppm. And it turns out there was a large interferent in the way, right in that same absorption. We added it in, and it turns out that the ammonia was more around 2.5, 3 ppm. So still below where the client needed to be, but it was apparent that the FTIR was not giving an accurate number on site. And if we did not validate and check this data set, we would have submitted the wrong numbers to not only the state, but to the client. Within the methods, and this is method 320, without going too crazy into all the wording here, and I'll briefly there's 3 slides here. I'll briefly kind of sit at each one. If you want to pause and kind of glance through, please feel free to do so. But long story short, this is really based around validation work. You can see here we're incorporating spiking, QA/QC, and actually overlaying the spectra, which you can see here, looking at the difference. So in the method, it is calling for you to validate the data. So why this isn't being done more readily is beyond me. I think it's a lack of understanding and maybe a little bit of complacency over time, but this step is so important. And I can't stress this enough. If there's one thing that you take away from this, presentation, it's validate your data. Ask for validations, make sure that your test teams are doing it. In terms of requests of what the states or the EPA is asking, I will say, if there are any test firms that are watching this, they are getting sharper with their request. And, this is a good thing. I think the FTIR for a long time has been wildly misunderstood. But as more people get better and more comfortable with the instrumentation, they're realizing how powerful and useful it is. This is an instrument that can be used for process optimization, for gas monitoring, engineering, compliance. Really, the list goes on and on. We can see hundreds of compounds. But in terms of actual requests, states have been kind of flying blind. They ask for the QA/QC, and if the QA/QC checks out on the report, they're not really going to question it. But what I do invite states to sometimes ask and request is, maybe a validation check. Let these firms show you, are they doing that very critical step? Whether that's a screenshot or a walkthrough, something along those lines. We are seeing the physical make and models of the equipment being requested, things like the resolution and path length. These are all relatively new requests, but they are important and they are coming up. They want to know about calibration gases. What grades are we using? How are your regulators? What is your transfer system? What's your sampling system? What QA/QC processes are you going through? Are you doing all the right steps? In the FTIR, there should be directs, system checks, spikes, and a slew of other challenging QA/QC things done throughout the day. If a 301 validation is requested, make sure you're doing that. And even on a deeper dive outside of QA/QC, actual spectral data is being asked for. Now, we can't release calibration data because that is property of MKS. But if requests are there to actually see the spectra, we can provide that information. And some states now, I can think of a few off the top of my head, have the software to where if they ask for the LRS, which are the light reference files, they can take references from the EPA, NIST, whatever it is, and they can compare to make sure that the number that the test firms are giving are accurate. This is a slow moving process, but what we're seeing is that everyone, particularly at the regulatory level, is getting better with the FTIR. For me personally, I think that's a great thing. This is something that I feel passionately about, and I know Phil would say the same. This is something that we spend a tremendous amount of time on. It's not everyone's favorite thing to do. I can assure you, doing validation work is not super thrilling, but there are complex data sets that do get interesting. But it is a very, very important step. Even if you're doing a simple combustion source and you're like, it has to be right, double check and just make sure that this step is being done. Aside from everything else that I talked about today, like I said, take away that validation is so important. I'm not going to throw anyone under the bus. I understand we all have a job, we have families, we're trying to do the right thing, but please ask for help. And as always, just make sure that your systems are clean, make sure that you're well trained, and that you know who to ask and who to go for. If you don't know who that is, by all means, email, call, text Phil or myself, and we can point you in the right direction. But we're happy to answer really any questions that you may have. So the end game for me, I want to see the FTIR continue to grow and succeed. We have to my knowledge, there's a couple firms in the country, and I'll leave it at a couple that are really good with the FTIR. Stick with those firms. They know what they're doing. They know what they're talking about. They have their reputation for a reason. Be wary of those who have just gotten into it. The FTIR there's no easy button. As much as we would all love to just, send a robot out and do the data collection, it's not that simple. It's very complex. It's come a long way, but it has a ways to go. So please, as always, ask lots of questions. And with that, I thank you for your time. It's a pleasure. I enjoy doing these quite a lot. If there's ever a need that you would like a more in-depth or private session, please reach out to Phil or myself. Like I said, we are passionate about this. This is really our bread and butter for what we do. We look forward to hearing from you. If you have any suggestions or thoughts, any complaints, let us know. We're here to grow together. We're a small industry in stack, but we want to know more and we want to help you out. So I thank you for your time, and I hope you have a great, blessed day. Thanks.